Okay, we are going to start Chapter 3 today. We're really just going to be looking at two sections here in Chapter 3. Today we're going to be talking about solving systems of equations. You're definitely going to want your calculator handy. I'm going to be giving you a lot of verbal instructions on the calculator. I'll be posting a few short TI-84 videos on my web page to show you how to do a few things that I'm going to be explaining to you here today. If you need to see the actual calculator for that, you can watch those short 5-minute videos to walk you through some different aspects. So what we're going to be talking about here today is we're going to be talking about different ways to solve what are called systems of equations. And essentially what a system of equation is when you have two or more equations and those equations have the same variables in them. Okay, and what your goal is to try to find the values for those variables that would satisfy all the equations that you're given. Okay, so solutions to all the equations. And we're going to be talking about three techniques here today: the graphing method, the substitution method, and then a new method to you on the calculator called the matrices method. So we're going to start with the graphing method because I think that you were introduced to this back in Algebra 1. With the graphing method, what you're basically going to do is you're going to graph both of the lines together, and then I think the key here is that the solution is whatever the intersection point is of the two graphs. So whatever points that the two graphs have in common, that would be the x and y solutions to technically both of the equations. So I'm going to be talking through these steps here. You can reference those. Before we go through these steps with these two examples here, I just want to scroll down through and show you kind of these three graphs that we have down here. When you graph two lines and you're trying to solve a system of equations graphically, you essentially have one of these three situations that could happen. If we're talking about linear graphs, which is what we're going to be working with here, these are graphs of straight lines that are not vertical. There's not going to be any curves or anything here. Option number one is that you have the two lines and you find that the two lines actually do intersect one another, and whatever that intersection point is, that is your one solution that you have. Okay. The other option, we're going to jump over here to this third picture, is that when you graph both the lines, it turns out that both of the lines are in fact parallel to each other. Now remember, your solution is any points that these graphs have in common. So if the two lines run parallel, that's when you would say that technically the system of equations has no solution. The third option is when you graph both the lines, it ends up being that both of the lines are in fact the exact same line. Therefore, when you look at the graph, it really looks like you're only seeing one line. And if our solution is supposed to be every point of intersection, technically every single point on both of the lines are shared because both lines are in fact the same line. So that's when you can't list what all the points are on a line. There's arrows on the ends here that go on forever. And so instead we just say that there are infinitely many solutions, or there's an infinite number of solutions. And you can see in this example up here that I did for you, what our first step is the first step has to be to put the equation in slope-intercept form. You can see I solved the top equation for y, I solved the bottom equation for y. If I were to type these into y1 and y2, you can tell that I'm typing the exact same equation in. And so in theory, I wouldn't even have to graph this because I can see that I'm really graphing the same line twice, which falls on this middle situation here where they're having an infinite number of points in common. So I'm just going to write that my solution is an infinite number of solutions. Okay, so that would be a situation where you actually would not have to graph it if you realize that both the slope and the y-intercept were exactly the same. Let's go ahead and try one here. Let's look at example A. Again, the first step has to be to solve the equation for y. So I'm going to go ahead and do that here. I'm going to move the 2x over. We'll divide everything by -1. When you get the equation solved for y, go ahead and circle it because you're going to need to come back and revisit that so that you can type it into your calculator. Okay, we're going to move on down to the second equation here. Again, I'm going to solve for y. I'm going to write it neatly how this looks here. This one has a slope of -5/2. Looks like the y-intercept would reduce to -8. Okay, so here's where on your calculator, hopefully you have your calculators out here. You would want to go into the calculator, go ahead and type this equation into y1 and this equation into y2. It mentions here in step 2 you're going to graph each equation on your calculator. Typically you just want to start in a standard viewing window, -10 to +10. And then if you needed to adjust your window in any way so that you could see where the two lines cross, you would want to do that. Okay, so we're going to type these in real quick here. Give you a second to go ahead and try to type those in. A quick way of resetting your window would be to press the zoom button and option 6. That resets it from -10 to +10. My graph, you don't have to draw the graph on your paper, but what I'm seeing here, if this is my X and Y axis, I'm seeing roughly one line that kind of looks like that and another line that kind of looks like this. So I'm seeing that there definitely is one intersection point. I need to find what the value or coordinates are of that one intersection point. And so here's where on the calculator you're going to press the second button and then the calculate menu. That calculate menu is actually under the trace key along the very top of your calculator. Okay. From that menu, you're going to choose option number 5 for intersect. You're wanting to find the intersection point of these two lines here. And it says here to move your cursor, use like the left or the right arrow to move your cursor over to that area where it feels like the two lines are intersecting. And then you're going to press the enter button 3 times in a row. 1, 2, 3. Finally, it should read intersection in the bottom left corner of your screen, and at the very bottom it should report what that intersection point is. This is the point -2, -3. So that's what you're going to write as your answer. If you were to plug a -2 in for the x's in both these equations and a -3 in for the y's, the first equation both sides would balance and the second equation both sides would balance. So that is your solution to this system of equations, and we solved it graphically. You have to show the work for how you are solving these for y. Okay, so we'll go ahead and do this with one more here graphically, and then we'll move on to substitution here. We're going to take a look at our top equation here. We're going to solve that for y. And divide by 3. Okay, there's one equation. Same thing here, divide by 3. Okay, here's my other equation. Now, technically speaking, remember what our 3 scenarios are. If you notice, now you do have to be careful though, if you notice that the slopes of the two lines are the same, and yet the y-intercepts are two completely different numbers. Technically this would be a 4 and this would be a -2. The two lines are not the same line. It's not this one, like over here when we saw this example here. See how the y-intercepts were the same and the slopes were the same? Well, then that's when I know it's really just the same line. If the slopes are the same but the y-intercepts are different, that's when we're dealing with two lines that are parallel. So I don't have to graph this one either. I can just simply write down that I know that this is going to be no solution, because if the two lines run parallel, they're not going to have any points in common with each other at all. Okay, I want to look at one other example of a graphing problem here with you. The way this one is worded, it's a little tricky for people, so I want to talk you through this, and I'm going to show you how to find the absolute value bars on your calculator. So here's what we want to do. We want to graph function h of x and k of x, and it says which intervals contain a value of x for which h of x equals k of x. Now remember, these are the y coordinates, so we're just trying to figure out what are the x coordinates essentially of the intersection points. Okay, well, that's what we want to try to find first. Okay, so here's what we're looking for. The x, I'm going to abbreviate, coordinates of the intersection points. Okay, well, you can tell that the two equations that you're given for h of x and k of x, these are not linear. Okay, this is going to be a parabola. I'm not sure if you're familiar with how an absolute value graph looks, but they tend to look like a V, kind of like that. So we're going to graph both of these together. We might have more than one intersection point since these are not linear. Okay, so on your calculator, if you could, go into Y1, clear that out, and how you're going to get the absolute value bars is you're going to press the math button and you're going to bump over to the num menu. It's the second menu. You should see the very first option should say ABS ABS. That's short for absolute value. Okay, newer calculators will make it look like absolute value bars, in which you can just type x minus 4 in between the bars. An older calculator will just still read ABS with a parenthesis, whereas you will type x minus 4 and then you'll close up a right parenthesis to show that's the end of the absolute value bars. You'll need to then hit the right arrow on your calculator to come outside the absolute value bars, hit +1, and come on down to Y2 and go ahead and type the K of X equation there. Okay, again, just press zoom 6. This is going to graph this in a viewing window here for you. And I think the calculator should show you a graph that it kind of looks maybe something roughly like that, where we have a V, this is our absolute value. We have a parabola, that's this function here, and you can see that we actually have 2 intersection points. Okay, so I'm interested in, first of all, figuring out what are the x coordinates. So you're going to do the same steps that we said right up here on the calculator. You're going to press the second button and then the calculate menu, which is under the trace key. Okay, so and then come down and select intersect. That's option 5. Now there's 2 intersection points. So right now let's just move our cursor to that far left intersection point, and you're going to tap the enter button 3 times in a row. Okay, and I'm just going to go ahead, I'm just going to write down what that intersection point is. That's crossing at -2, 7. I'm going to repeat that same process. Second, hit the calculate, the trace button, option 5 for intersect. Now move the cursor over to the other intersection point. That would be this point over here. And again, press enter 3 times. We're going to write down that that's the point 1, 4. Okay. Now, I'm interested in the x coordinates. That's -2 and that's +1. Now look at the answers here. I'm given intervals for which x falls between. So you want to take this first x value, -2, and you want to ask yourself, is -2 a number that is between -4.5 and -3? It is not. Well, is -2 a number between -3 and -1.5? Oh yeah, it is. So I'm going to check that box because -2 falls between those 2 numbers, and then we want to look and see, well, between which 2 numbers would this x coordinate fall in? The number 1. Well, it looks like that would fall between -1.5 and +1.5. So those are the 2 boxes that I would then check. Okay. All right, I'm just going to go ahead and just talk through what we would check here. Here's one more by graphing. Essentially what you would do is you would graph the 2 equations that you're given in this first row, and you would look at the graph and you would simply put a check mark in the column based on whether the graph looked like it had no intersection points, 1 intersection point, or 2 intersection points. Okay, if you were to graph that first one, there should be 2 intersection points. If you wanted to try this on your own, you could go ahead and pause the video, kind of graph each of these 3 sets and put the check mark where it looked like there was 1 or no intersection points. I'm going to go ahead and fill the check marks in. You can go back and kind of check yourself, but that's where the check marks would go there. Okay, let's go ahead and look at a second method, the substitution method. This is probably the most involved. The substitution method, again, we have some steps here. What you're going to do, I know with the graphing method, you have to solve each equation for y. But with the substitution method, you're going to solve one equation, and it doesn't matter which variable you solve for, but let me give you a tip. It's easiest to solve for a variable with a 1 in front of it. Now, sometimes you don't have that, but I would look at the 4 variables. We have x, x, y, y, and I notice that this y right there has a 1 in front of it. When I look at the second example over here, x, x, y, y, I notice that on that one, that x has a 1 in front of it. So the easiest way to do these problems is to choose to solve the equation for the variable that has a 1 in front of it. So I'm going to do that for both of these equations. I'm going to solve the first problem, that second equation for y, and in the second example, I'm going to solve that top equation for x. Okay, now look at the second step. It says substitute the resulting expression into the other equation to replace the variable. So here's what we're saying. We're saying that a y is equal to a -2x plus 7. So we should take this -2x plus 7 and we should substitute that expression into the top equation exactly in the spot where the y is. And here's what that does for us. It gives us an equation that now only has one type of variable. See how instead of the top equation having x's and y's, it now has all x's? So we should be able to just use our algebra skills, distribute the -3, and solve this equation for x, and at least we will know what x equals. Looks like x would equal 4. Now that's only half of our answer. We're going to always write our answer as a point, but we know that the x coordinate is a 4, so what we want to do now is we want to take that answer of 4 for x, and the best way or place to plug it back in, technically you could plug it back into either of these two equations for the x's, but it's a little easier to take this equation that you've already rearranged and solved for y, and solve that equation for y with an x plugged in. So -8 plus 7 looks like -1 is the y coordinate. Okay, let's try that same thing one more time over here, and then we're going to take a quick look at matrices. So I solved the top equation here for x. So I'm going to take this expression, 7y plus 11, and look where I'm plugging it. It goes into the other equation. So right where that x is, I'm substituting 7y plus 11. Now I have an equation that consists of all y's, so I'm just going to use algebra again to distribute, combine like terms. If I move that 55 over to the other side, I believe I get -78, and the y value ends up coming out to be -2. Okay, so I know that the y coordinate is -2, so now I'm going to take this y value. The best place to plug it in is the equation that I already have rearranged and solved for x. So I'm going to go back to that, plug -2 in, and I end up getting -14 plus 11. I get -3 for the x coordinate. By the way, if I graphed both of these would both show you lines that intersected at these points that we're getting here. Okay, we're going to look at a new method here real quick, the matrices method. Again, you want to have your calculator out and handy. Everything I'm going to explain to you verbally is in these steps that you'll see right here, and I'm also going to post a video of me explaining each of these two examples very, very briefly, just kind of showing you how it looks on the calculator. You could access that on my webpage as well. Okay, so here's what you're going to do. The very, very first step is you have to arrange your equation so that all the variables are lined up vertically, and this includes the equal sign. So just kind of think maybe a little bit like standard form when we talked about it before, where you want to have your x first. So I'm going to rearrange the first equation. So the x is first, y is second, then my equal sign, then my constant. The second equation looks like it was already like that, so I'm just going to recopy the second equation underneath the first one that I rearranged. That way, see how I have everything lined up vertically: x's, y's, equal signs, and constant. Okay, the next thing you're going to do is you're going to write down, this is called the coefficient matrix. See here it says enter the coefficients of the variables into matrix A. Now I want you to write down on your paper, always write down on your paper what the coefficients are. Coefficients are just the numbers, they are not the variables. So you're going to write down 5 here, 3, 8 here, 3. Okay, we're going to call this, that is going to be matrix A. Okay. Now, before we put that in, well, let's go ahead. Let me talk you through how to put that into your calculator. Okay, on your calculator, you're going to press the second button, and you're going to select matrix. Matrix is along the left side of your calculator. It's underneath the x to the -1 button. You should see the word matrix. Okay, I want you to bump over to the edit menu and select option 1 for matrix A. Now, the cursor is going to be blinking on what are called the dimensions of the matrix. Okay, get this. You need to change those dimensions so those numbers coincide with how many rows you have and how many columns you have. This matrix A has 2 rows and 2 columns, so it is a 2 by 2 matrix. Just go ahead and type 2, enter, 2, enter, and it'll create a matrix underneath that kind of looks like it has 4 spots for you to type numbers in. Okay, you're going to go ahead, the way it fills it in is it types it in moving across the rows. So you're going to type 5, then hit enter. It should bump over to this spot. 3, hit enter. It'll jump down here. 8, enter. Finally, 3, enter. Okay, you have just entered the coefficients into matrix A. Okay, now what we're going to do is we're going to enter the constants into matrix B. What I always want you to show on your paper is first I want you on your paper to just put the variables in order that you see them going from left to right in your equation. So x, y, you're going to fill these in down this column here. Put an equal sign, and now this is going to be your constant matrix. And that's basically the two constants that are on the other side of the equation. This is what we're going to enter into our calculator here for matrix B. Okay, we're on step number 3 up top. We're going to enter the constants into matrix B. So again, press the second button, hit that x to the -1 button that says matrix underneath it. Go all the way over to edit, only this time select option 2 for matrix B. Now remember, the dimensions are, we said rows first, then columns. Rows, then columns. So if you look at matrix B, you can see that we still have 2 rows, but matrix B only has 1 column. So this should be a 2 by 1 matrix. Okay, the dimensions are 2 by 1, whereas for A it was 2 by 2. Okay, then go ahead and fill in -19 and -25. This is the only work that you really have to show on your paper. This shows me what you typed into your calculator here, folks. Okay. Now, to actually get the calculator to give you the answer, you need to go back to the home screen. So you're going to hit the second button, and right next to it where it says mode, press that. That's the quit option. Takes you back to the home screen. Okay, what you're going to do is you're going to take the inverse of matrix A and multiply it times matrix B. Here's how this is going to look on your calculator. You're going to press the matrix button again. So second matrix. But don't go over to edit, just immediately tap number 1 underneath where it says names, matrix A. And this is what you should be seeing on your calculator screen. It should paste matrix A just right there like that. Okay, to get the inverse of matrix A, you have to press that x -1 button. It'll put a little -1 right there. Okay, then hit the matrix button again, second matrix, and immediately press option 2 for matrix B under names. It should paste this symbol right after that. Okay. Now again, if you're wanting to see the calculator screen, you want to watch the 5-minute video that I'm going to post on my web page underneath the TI-84 calculator videos. When your screen looks like this, you can go ahead and hit enter. It's going to spit out on the side the answers. Okay, and basically these answers right here represent this variable matrix, but with the answers plugged in. So the top number is your x, the bottom number is your y, so your answer is -2, -3. Okay, we're going to try one more quickly here. Okay, let's take a quick look at example B. We want to get everything in order. I'm just going to clean this up just a little bit here. Okay, so I got, it's looking like my y's aren't totally in order. I need to kind of do a little rearranging of these two terms like right there. So I'm going to rewrite the top equation. That looks good. When I write this middle equation, I'm putting the 9y in the middle and the -4z at the end. And I think the third equation looked good. So this is everything stacked properly, so everything's lined up. Okay, on my paper, I'm going to write out matrix A. This one needs to be a little bit bigger. Remember, the coefficients. Be careful, guys. If you don't see a number in front of a variable, like that x and this y down here, you should be using a 1. So 1, -9, 4, -2, 9, -4, 2, 1, -4. Okay, we'll put those in the calculator here in a minute. I'm going to write the variable matrix now, x, y, z, and then equals, and then I'm going to put my 3 constants, 1, -3, -3. Okay, remember, matrix A is this first coefficient matrix, and matrix B is that last constant matrix. Now, matrix A has 3 rows and 3 columns. So the dimensions for matrix A are a 3 by 3 matrix. So again, if you follow the steps back up here again, you're going to press second matrix. Anytime you're changing what's in the matrix, you need to bump over to the edit menu, choose option 1 and change those dimensions to 3 by 3, and then start typing in across the rows. You'll hit enter as you go and it'll fill all these in. So take a second, type all of those in. Okay, once you have that in, now we need to put matrix B into our calculator. So let's look at what the dimensions are going to be for this. There's 3 rows still, but matrix B only has 1 column. So the dimensions for matrix B are 3 by 1. So go back and hit second matrix, all the way over to the edit menu. Choose number 2 for matrix B and change the dimensions to 3 by 1. That should allow you to type these 3 numbers in here. Okay, when you've got matrix B filled in, now you want to go back to the home screen. Press second mode or second quit. Okay, this is what we want our screen to look like. So we need to get this symbol for matrix A there. We do that by pressing the matrix button again, only this time instead of going over to edit, just immediately press the number 1. Okay, that's going to give you that symbol. Okay, we need to say that we want to take the inverse of matrix A. We need a little -1 there, so just hit the X -1 button, and then we need to put matrix B here. So again, second matrix, option 2, go ahead and hit enter, and it should spit out for you that this answer is the point 2, 1, 2. That would be the answer to this one. Okay. If you get an error when you're doing these matrices problems, it means you probably mistyped a number, forgot to rearrange the equation. You should not be getting errors for these matrix problems. Okay, you can see that your homework assignment is for you to complete worksheet 3.1. It's very important that whatever method the directions ask you to use, you need to make sure you are using that method and you're showing those steps to support your answer. All right.